Welcome to this talk. Thanks for coming. So this is talk about Clojure, and this is more of a personal experience rather than evangelism about Clojure. This is why I like Clojure and why I prefer to write in Clojure most of the time. And the first thing that I want to talk about is a little bit of experience of me. So I started reading Pragmatic Programmer some time ago, and there was a very decent quote from that one that said, hey, learn at least one new language every year. So I tried most of the time. So this is my history of learning programming languages. So I started coding in BASIC in 1994. That's for fun. And then later I wrote in Pascal and C, and then later Visual C++. I did some Windows development. And then I started learning Java sometime around 2002. And from 2002, pretty much most of the time I've been doing Java and working on JVM languages, apart from Perl and Ruby here and there. So obviously, JVM is something that we like because that's, as everybody was pointing out, it's a very technically amazing platform. And we love to hate it because of the exceptions or the stack traces, but at least, thank God we have stack traces. And funnily enough, this is a screenshot from the stack trace that I got yesterday trying to connect to some Wi-Fi spot here. But there are also privileges being on JVM, especially nowadays. There is a plethora of languages that are available on JVM for you to choose from, and each language has its own strengths and weaknesses. So if you see the different types of languages, so there is JRuby, Jython, Kotlin, Phantom, and Frege, of course, and Clojure. So And I wanted to pick one of these languages to try out and learn the new functional paradigm because I'm more into functional languages. And my choice was Clojure. So this is more about why Clojure. And then obviously some people ask me, okay, why not Haskell? So Haskell doesn't have any side effects. So obviously nobody runs them. But JVM being the fundamental engineering marvel, we want to stick to JVM. So what is Clojure? So Clojure is basically a dynamic, functional, immutable Lisp. So it has dynamic typing, and it has very spectacular concurrency support with its primitives. And it runs on at least 3 platforms. So it runs on JVM, it runs on JavaScript, and it runs on CLR, but we really don't care about CLR. And also, because it being a Lisp, it is extremely flexible due to its dynamic nature. So you can define your model or the domain model, and then you are free to change the model whenever you want. So there is no type system to fight with. And it's extremely concise. It's some people think that Lisp is one of the most beautiful languages due to its conciseness. And it also encourages experimentation and exploration. As I said, it's a dynamic language, so you get to do a lot of experimentation using REPL, for example. And you don't need to worry too much about types or anything, so you can just focus on the business domain. This has been one of the primary reasons why I like Clojure so much, because the rest of the thing is basically ceremony. That's what I see nowadays. People want to try Python, want to try Ruby, want to try Frege, or want to try Lisp or Clojure, for example. So you can actually focus on the business problem and then deal with it. That's what you're trying to solve. You're not trying to make the compiler happy. That's not going to solve your business problem. So another biggest advantage that Lisps have, that Clojure inherits basically, is the REPL. And I hear that every language nowadays has a REPL. The Java is coming up with JShell, and Scala has a REPL, and everybody keeps on saying it's a REPL. But it's not something similar to what you have in Lisp, because in Lisp, the reading and evaluation are different steps. You are dealing with the data structures. But I'll talk about it a bit later. And also you can do on-the-fly function definition. And of course, REPL is essentially the tool for interactive development. So why Clojure? Because Clojure is simple and elegant. But that's a big claim. The biggest claims need biggest proofs or something. So obviously, one of the seminal books in programming, I'm not sure how many people have read this book. Awesome. Okay. So there is a list of books that people say that they read, but they want to read, and this is almost falls in either of those categories. So structure and interpretation of computer programs, for the people who don't know about it, this is one of the books that introduces Lisp from the computation point of view, how a programming language helps you to define computations. And it defines that every powerful language should have at least three fundamental qualities: an ability to create primitive expressions and some means of combination, of combining those primitive expressions, and also a means of abstraction. So in Clojure, let's see what Clojure provides. So Clojure has the primitive expressions, which is basically, some people like to call it the atoms or atomic data types. So Clojure has integers, doubles, big decimal, and ratios. Ratios is a proper high level or a primitive concept. So you don't need to have a weird looking number there. You can have proper ratio as an atom. And you have strings and characters, of course. So there is examples there. Clojure is a string. You can have characters, which is basically backslash the character itself. And then you have symbols and keywords. Symbols are the things that you use to name the things. So you want to combine a couple of things and then give them a name. So that's what you use symbols for. And then keywords, basically, they refer to themselves. And you have booleans, and you have null. Obviously, you cannot avoid null. You're on JVM. So booleans are basically have two values, true and false, and null is essentially nil. And also there is a support for regular expressions. So you can write a regular expression by just typing hash and then put it in the quotes. Now that is the primitive expressions. Now you want to think about how can you combine the things together. So the combining things happens using data structures in Clojure. So you have lists. So lists are basically singly linked lists. So they're prepend friendly. By that I mean that you can keep adding items to the list and it will grow in the front. And then as you might have noticed that the list contains the first form is creating a list using the list function. And the second form, as you can see, it doesn't have the similar values. So the lists are heterogeneous. All the data structures can contain any values in them. So you do not create a type of list that only contains integers. It applies to other data structures as well, as you can see in the examples. So then there are vectors. Vectors are indexed, so they're very fast if you want to access based on indexes. And they're append friendly. By that I mean when you add a new item, it is very efficient because it's going to be added to the end, not to the front. And you need maps, which is basically key and value pairs. So the keys can be anything. So in this case, in the first case, the keys are the keywords, and in the second case, the keys are the numbers. So that is a map. And then you have sets. Sets are just like mathematical sets. You have unique values across the set. So these are the data structures that Clojure provides as a means of combination. And also the other part thing with these data structures is that they're nestable, as in each data structure can contain other data structures. So as you can see on line 1, it's actually a list from the outer parentheses, and it contains a symbol, hello, and the vector names, and a list of strings, hi and everyone. And then on the line 2, you see a vector containing a list and a symbol 1, and then a vector again. And obviously the third one is a map that has a keyword called planets, and then there is Earth, Mars, and Pluto. I still think Pluto is a planet. I don't know who. Okay, thank you. At least a couple of guys. So another nicest thing with all these data structures is that they're immutable and persistent. So this is what you keep hearing in all the functional programming languages, that immutability is one of the key features. So all these data structures are immutable. And once you create them, you cannot modify them. Obviously, that sounds stupid unless you think about it. So when you make an immutable data structure, then all you're doing is, if you want to create a new data structure out of that one, then you're going to either append or prepend to the tree. So that's what it is meant by persistent data structures. So Clojure implements persistent data structures that are created by or invented by Phil Bagwell. And then they're into Scala as well, and also in Clojure. So that's it. That's essentially Clojure. I mean, there is nothing else that you need to learn. So Clojure has no syntax to learn for. If you know these concepts, then you can read any Clojure code, because there is nothing else. But of course, there is a small caveat. So in Clojure, data structures are code, and code is data structure. So you can produce the code using the code, because what you're writing is data, and then the data is being evaluated by the Clojure reader and evaluator. So let me show you a simple example. Like every decent programming exercise starts with a hello world, but this is going to be hello event. So here I have 2 lines on this program. So the first one is, again, if you remember from the syntax or the no syntax, the first one is basically a list of 2 symbols. First one is NS and the second one is hello world. So what it's essentially doing is creating a namespace called hello world. So namespace is like a module. So you can group functions or related things together. So you can define it's similar to package, but in some ways. And the second line says, okay, define a function called say hello. And again, the entire line is basically a list. So there is nothing that you don't know about, except that what individual things mean. And define is for defining a function, and say hello is the name of the function, and it takes 1 parameter, which is called a parameters vector, and that's an event. And then you have the body of the function, which is essentially print hello and then event. So if I run this program, this is what I see. So I'm going to call the function using say hello and then pass it a parameter that is going to be bound to the symbol that is event in the scope of the function. And then it prints hello Devoxx, and then it returns nil, because PRN itself, which is print one line, it should return some value, so it is going to return nil. But it has a side effect of printing something. So to recap, data structures are code. Everything is just a list. So all of the things that you see in Clojure are essentially a list. So declarations, defining a new variable, because there is no mutability there, and defining new symbols for that matter. I think that's much more correct way of saying it. And then there are control structures like if, else, or whatever. They're basically lists, and functions are lists, as you have seen in the previous slide. And then there are operators, which are also, again, just lists of things. Now, this is how it looks like. So every list is interpreted as the first one being an operation, which is either a function expression or a macro, or maybe there are some few special forms. So you need some sort of building blocks to build up your language. I'm not sure how many have you read the paper by John McCarthy about constructing Lisp. So it's essentially 7 forms that you need to use to construct the entire language. So it is something similar, but because Clojure being running on JVM, there are a couple of things that are needed for Clojure. For example, to account for the lack of tail call optimization, there is a loop and recur for recursive functions or the loops. And then there is also a trampoline function that you can use, but we'll come to that later. And the throw and try, these things are, they're just Java try and throw. And so essentially it's 14 or so special forms. So there is very limited cognitive load on my mind. I'm just an average programmer to learn new syntax or anything. I'm productive immediately, at least from my perspective. Now, when I contrast that to some other languages, this is a example from Stack Overflow. So what are the uses of underscore in Scala? So underscore essentially means 11 things. And I really love that the answer ends with, there may be others that I have forgotten. So that's pretty awesome. Anyway, so Clojure, the second reason is that Clojure is a functional language. Nowadays, everybody wants to write functional languages because we all know that, I think we are in the same page that we agree that we are going into this multi-core world of awesomeness, and we need better languages to deal with that situation. And obviously, functional languages are the way to go. And so the fundamental reasons why functional languages are better is that they're easier to reason about. In some languages more so, for example in Frege, because there are no side effects at all. And they're easier to test because you're defining smaller functions, and you can deal with the functions, and then you can just test those functions as long as you can write in a purely functional way, or at least as much as possible. And immutability is also baked into Clojure. As I was explaining, all the data structures that Clojure provides, they're fundamentally immutable, so you cannot modify them. And this is a big win for concurrency and possible parallelism. So that's the idea. And just like every other functional language these days, functions are first class, so you can they're just symbols, and you just give a symbol or a name to a function, and you can just keep referencing them and then pass them around and do whatever you like. And they're also higher order functions. So you can, that's what essentially what is the result of functions being first class. And it supports recursion using loop and recur. Obviously, the regular recursion that you are, if you know, in Scheme or other Lisps, that's not possible because the tail call optimization isn't there. So loop recur is one way, like a escape hatch. And if you need mutual recursion, then you end up using trampolining, which is again another function in Clojure. So Clojure has, the third reason, Clojure has great support for concurrency. So this has been one of the biggest pains that at least I faced in Java, because I built a lot of desktop applications as well, using SWT and Swing and a lot of other technologies in Java. And concurrency is something that is very, very hard to get correct. And especially for, if I'm not very cheeky. And so that makes it even more difficult for me, because I'm going to spend more time on getting the technical foundation right than actually solving the business problem. So I'd really like somebody more smarter than me trying to figure out all these problems for me. So that's what I think Clojure provides me. So in Clojure, there are no locks at all. So because there are no objects, there is no global shared mutable state. All the state is in the data structures. They are immutable and they are persistent. And there are some concurrency primitives like vars, atoms, and agents. And there is software transaction memory that gives you similar transactions, fairly similar to the database transactions. So you can replace or work with different kinds of data without worrying about are there any deadlocks or anything. So to give a small comparison about what these things mean, so this is a comparison of different kind of concurrent primitives that you get in Clojure. So vars are the things that are essentially thread local things or objects or whatever the values that you want to have. And that's what you've seen so far. In the code, when I created a def and whatever, that's basically a var. And then you have atoms. So atoms are retriable, as in you create an atom, and then atom has a state, which could be any data structure. And there are functions that help you to update the atom or change the value in an atom. And you can have series of functions that are going to modify this atom, but everything is going to be retriable, as in it will retry applying the same value again. And you can dereference an atom at any point of time in your program, and it will continue giving you the current state of the atom without you need to blocking a thread or anything. And finally, there are agents. Agents are more asynchronous, and atoms are more synchronous in the way that you're updating the code. And agents are similar, but they're asynchronous. So essentially, it will create a different thread to update the agent. And then there are refs. Refs are the fundamental idea behind, or the fundamental construct that you use if you want to do software transaction memory. The special feature of the refs is that they are coordinated. That means all the reads and writes of multiple refs, you can do that without any problems with race conditions. And so these are the fundamental ideas. But obviously, there is these are enough to when you're working in a single program, or when you're working in a program where you just need to handle your concurrency in some ways. But still, one of the problems with concurrency is when you keep creating these futures or the delays and other things in your program, then you end up having all sorts of callbacks and weird things. So for that, there is a new library called core async. And it's not new anymore because it has been there for some time now, and it's out of alpha now. So this provides something called a channel-based concurrency. So there are different types of concurrency models in different languages. For example, Scala primarily uses actors, or they say that actors are the best way to handle both parallelism and concurrency. And you have in Go you have channels, which is baked into the language. But in Clojure, channels are just a library, so there is no syntax for it. You can just use them by adding it as a library to your program. And it also works on JavaScript, because this is what Clojure has been built for, to be ported onto different languages or different platforms. So the same core async channel-based concurrency, which helps you preventing this callback hell, you can also use it on JavaScript. Obviously, on JVM, it's not that useful because you have multiple threads on JVM, but especially when you switch to JavaScript, if you are writing for Node.js, which seems to be very unpopular here, and then all you're left with is just single thread. Especially in the browser, you only have single thread. Then you keep adding all these callbacks and promises and whatever. That makes things way complicated. So that's the concurrency story that you get from Clojure. And then you have the next reason that I think Clojure, why I love Clojure, is that Clojure is practical in a sense that it's very host friendly. So especially on JVM, there is no bridge, there is no gap between the JVM and Clojure runtime. So some languages, for example, there was a Ruby implementation on top of Objective-C, and there is a bridge. So for every object that you see in Objective-C, then they created a proxy object in Ruby. So that makes things a lot more complicated, and that's one of the leaky abstractions, and sometimes you need to get into Objective-C world. And but in Clojure, there is no difference between the data that you have on JVM, on Java. So strings in Clojure are basically Java strings. And all the numbers that you have in Clojure, they're essentially Java numbers. And all the collections, they implement the collection. And there is no conversion needed if you want to use any of those proper objects that you have in Java. So in Scala, for example, you need to import these Java conversions to ship your Scala collections into Java world and Java collections into Scala world. And all the functions, they implement runnable. So they're pretty much JVM things. And using the Java libraries is extremely easy because there are a lot of syntactical constructs that you can use to make my life easier. So there is dot notation, and creating new objects is fairly easy. And I don't want to go into too much syntax details into this talk. Obviously, you guys can just look it up on the net and the documentation. And the next feature that is fascinating in Clojure is that the ClojureScript. So this gives me a single language that I can use to build, because mostly these days, I think everything is web application driven, and everybody is obviously building most of the time web applications. And so that's what I'm interested in as well. And we see that even the editors are now web-based or the WebKit based. That seems to be the hipstery thing to do these days. So we have ClojureScript, which basically compiles to JavaScript, which is essentially the core of the language. Pretty much all the features of the language are supported in ClojureScript. And it has some fascinating tools. So for example, how many of you have seen the Brett Victor's presentation about live coding stuff? Yeah. So it was a crazy demo. I mean, when he gave the demo, everybody was just jumping onto it and how to make this one in every other language possible. So in Clojure, of course, we have Figwheel, which is a fantastic tool that you can just keep writing the code, and then the browser keeps refreshing, and you can build your entire application without once stopping the whole thing. And obviously, the UI coding is very easy, but you need some way to manage the state. And the whole state management is also facilitated by the nice immutable data structures in Clojure, which are ported to ClojureScript, obviously. And the availability of the concurrency primitives, only Atom, I think. So Atom is available. And there has been a lot of integrations with React.js, React.js being the latest way of building scalable user interfaces. And ClojureScript has been the early adopter, so to speak, of React.js. And then they built amazing libraries, Ohm being the first one, and Reagent is more or less very popular library in Clojure world. So if you're interested in Clojure and ClojureScript, I think you guys should take a look at React.js integration stuff. And also, the ClojureScript has macros. Obviously, ClojureScript doesn't have any runtime, but the macros are facilitated by Clojure language itself. So you write the macros in Clojure, and then you can still use macros in ClojureScript. So macros, for the people who don't know, those are the things that write the code for you. Not for you. That means you cannot hire them to do your job, but rather they're going to produce the code, and because it's essentially the same data structures. And the other practicality of Clojure is that Clojure seems to, or the Clojure community seems to prefer libraries than frameworks. So if you come from Java world, especially back in the days when there was struts or whatever, then everybody was building the next big framework. So you just buy into the framework and you build the whole thing within that sandbox, within their, within their framework. But in Clojure, the general idea of the community seems to be, let's make single usable libraries and let the developer decide how he wants to build his entire application. So that's the thing that I really like about Clojure. And then if you see, then obviously that means you need to have a lot of libraries. So if you see Clojures, for example, that is the central repository for Clojure, or at least most of the guys who are doing the Clojure right now. So they have around 14,199 libraries, obviously not at a CPAN level for the Perl guys here, but at least very reasonable amount of libraries. And practically nowadays you can find any library that you want for your use case. And also, as I said, because there is a lot of there is no friction interop between JVM and Clojure, or the Java libraries and Clojure, you can just use any Java library very easily. And a lot of these libraries are essentially a wrapper around Java API to make it more Clojure friendly. For example, all the way from MongoDB to Spark to Elasticsearch, and practically every library that you have these days that has Java API has a wrapper, high quality wrapper for Clojure. And just having an awesome language and awesome libraries is not enough, because you go through a lot of pain every day by just running some tools which call themselves simple, right? So they say there are simple build tools, but they're not essentially. They're the bane of your existence sometimes. But Clojure's build tools, these things are even appreciated, or rather, they're encouraged, or rather acclaimed by other people as well, even from the other languages. For example, Leiningen, which is like the de facto build tool for Clojure, which uses Clojure data structure to define a project. So you see the simplicity across the stack. And obviously, Leiningen had been long enough, and as a community, they saw some drawbacks in Leiningen. And then there is a boot, which is much more task-based build tool for Clojure. And these are extremely easy to get started with. And that's a fundamental thing that I really like in Clojure community. And then, so you have nice language, and you have nice libraries, and you have nice build tools, but every day you're going to spend practically full screen IDE or an editor. So if you don't have any proper support for an IDE or editor, then there is no way you could write. I'm pretty sure there are people who use Notepad++. I saw some awards for Notepad++ there, but I missed the butterflies and the eddy current stuff. So maybe nobody is using that one. So all the editors, that there is only one true editor, obviously, that's Emacs. And Emacs has fantastic support with Cider, which is a community-driven project, and it has amazing support for Clojure, and the way that people are contributing to that one is crazy. And the ideas from Cider, for the people who are more into Java, are much more used to IntelliJ shortcuts. Then you can also use a plugin called Cursive Clojure, and that has all the niceties of Emacs, including the very famed paredit mode. If anybody is familiar, then it's a way to edit Lisp code as data structures rather than data. And very nice language, simple and elegant, nice libraries, nice concurrency primitives, and nice editors. But also what you need is, programming is fundamentally a social activity. You need a vibrant community. So that's what I think Clojure has. I have been part of the Clojure, at least on the IRC, since 2005 or something. So I keep idling on IRC and talking to other people, and the way they help me out and the way they explain things to the new people is fascinating. And if you see the size of the community, Clojure mailing list has around 10,000 something members. 10,569. I just took the screenshot today. And so it has very healthy amount of traffic, people building newer things and people using a lot of things in production. And there is also the new Slack thing. Nowadays, everybody needs a Slack channel for one reason or the other. So Clojure has a community-driven Slack channel or the Slack site, whatever you want to call it. So there are around 166 channels grouped around different libraries, different for beginners or for advanced people or people using Emacs, people using IntelliJ. So you can just join in, ask questions, and get help from others. Or if you're knowledgeable, then you can help the others as well. And obviously, there is still IRC, so you can join IRC as well. And so you can. These are the things that you can get from the internet, from the documentation by looking up. But you need some sort of a structured way of learning a language. So this is also a bigger question, whether you have sufficient resources to learn this language or not. So for Clojure, this is just a snapshot of how many books and resources and videos available for Clojure. So there are more than 20 books available at different levels, so you can pick Clojure and then pick one of those books. Especially there is a new book by Karin Meyer, I think, called Living Clojure that is very beginner friendly if you want to get into Clojure. And obviously there is Joy of Clojure, which is even if you don't want to use Clojure, I'd really recommend reading that book just for the fun of it. So to summarize, why Clojure? Because it is simple and elegant, and it is functional, it has great support for concurrency, it is a practical language, and it has a vibrant and friendly community. This is why I'm using Clojure, and I hope some of these reasons might resonate with you guys, and then you might want to try it out. So that's the thing that I hope that it would help. But obviously, this all still looks like I'm talking about Clojure is the awesome thing and why you should use Clojure. But then why not Clojure? So you'd like to know why, what is the reason why I should not use Clojure? So there are different types of languages available nowadays. So I'm trying to, this is just my impression of the thing. So I might be wrong. So you have pure languages and impure languages. You have lazy and strict in terms of evaluation. And you have static and dynamic in terms of typing. I'm not getting into weak typing thing. I'm only talking about strongly typed, either static or dynamic. So Clojure falls into this category. So it is impure as in the function can do whatever the hell they want. So you can write printlns at any point of the time that you want to put in. And Clojure is essentially lazy because all the functions are lazy in Clojure. So if you create a range function that is going to, that is, if you don't provide any arguments, then it is going to give you, 1 to million numbers. But obviously it's lazy, so it's not going to actually fill up your heap. And it's a dynamic language. That's what I explained before. It's a dynamically typed language. And maybe if you lean into the other way, then you can pick Frege, for example. And then Frege it's a pure language. It's a Haskell-based language, obviously. Inspired by Haskell. It wants to be a Haskell on JVM. And if you want to pick, obviously it has lazy semantics, or the lazy evaluation, and then it is a statically typed language. So you have two different nice tools to pick your thing to your liking. Sorry, but there is some sort of experimentation or the idea that how you are going to use these two languages. So you have the surface area which you want it to be typed. And then you have the internals where you really don't care about types. You want to deal with the data. So you can mix and match different languages. And obviously, there is Scala. And so Scala has impure stuff, pure stuff, lazy things, strict stuff, and it is static. Maybe it's not dynamic. Well, you can make it dynamic. Just call everything any val and you're done. But I wouldn't recommend it. So please don't consider this as it's just a friendly nudge to Scala, guys. So that's the reason. So it depends on where you fall in and where your preferences are. So there is no one true language. There is no one thing that is going to solve all your problems. So you want to pick the right tool for the right language. So in my opinion, Clojure is more about a language that is going to be data-centric, that provides the beauty of Lisp, and you can pick Clojure as the thing. So as I looked up the schedule, and as a follow-up, I see that there are a couple of talks coming up. The next one is by Joe Kuttner. He's from Heroku, and he's going to talk about a bit of Clojure as well. So if you're interested in web frameworks in Clojure, he's going to talk about Luminous. That is one of the web frameworks in Clojure. And also there is another talk by Lutz. He's from TypeSafe, and he's going to talk about different concurrency models in Clojure. So because he's going into a bit more detail into channels and other stuff. So I recommend you to pick one of these talks and continue on this one. So that's it from me. It's a pretty short one, but I'm happy to take any questions. Yeah.
You say that because we're on the JVM, we can't avoid null.
Yeah.
But surely that can actually be enforced at the language level. If you've just got something which returns a void,
Yeah.
which is not a null, and then anything which returns something which could be null is basically just forced into an optional type. Isn't that one way of working around that? It seems.
Yeah, so the optional types, sorry, the question is how do you work around nulls?
The question is, why do you have null when you can enforce the possibility of not having null at the language level?
Okay, so the question is more about if we can have some sort of a language level construct that can prevent the null happening.
Yeah.
Okay, so but in Clojure, because there is no type system available, so you can't actually capture that information as a type. So all you have is either null, which is basically nil, and most of the time, nil evaluates to false, and there is no, as I said, type system to capture that information. But I see that happening in most of the other languages, they have different static type systems. Any other questions?
Yeah, me again.
Okay.
So you said in some languages you have this bridge. So I think was it some root.
Yeah, macroB. Yeah.
And you have proxies.
Yeah.
But then a little bit later, you said you have libraries which basically wrap
Yeah.
JVM libraries.
Yeah.
Isn't that roughly the same thing?
Yeah, so the question was about some languages have wrappers around the objects, but then I said the libraries are wrappers around Java API. When I said the libraries are wrappers around Java API, they're just wrappers around the API, and they provide the objects as it is. For example, if you're dealing with the Spark wrapper for Clojure, you get RDDs, because Clojure still have types. They're just dynamic. So you still have those objects with types, but there is no toll bridge for the objects. So you just use RDD as an RDD in Clojure, and I can call any function or any method to quote proper object-oriented terms, any method on the object. So there is no, I don't think there are conflicting statements. Any other questions? Okay. Thank you. Thanks for listening.